Factoring a trinomial when c is negative is by far the most challenging of the factoring problems because having a c that is negative gives us the largest list of possible factors. Because when your c is negative, that means it's a product of a positive number and a negative number. And it could be that the larger number is positive, or it could be that the smaller number is positive. So the list of possible products can get to be quite long, even if the number itself doesn't have a lot of factors. So let me show you what I mean. In this problem, the b is 3 and the c is negative 18. We can go to b and c and straight to the parentheses because there's no greatest common factor. We start with x because the problem has x squared. And now we're looking for numbers that have a product of negative 18 and a sum of 3. And as I said, a product of negative 18 means one positive and one negative. So it could be negative 1 times 18, which is negative 18, or it could be 1 times negative 18, which is also negative 18. What's the difference? Well, negative 1 plus 18 is 17. But 1 plus negative 18 is negative 17. And we're looking for one that has a sum of 3, so this is not going to do it. What about 2 and 9? That could be negative 2 times 9, or it could be 2 times negative 9. Those are both negative 18. Negative 2 plus 9 is 7. And 2 plus negative 9 equals negative 7. Now, if you're looking at this and you're thinking to yourself, there's no reason for you to do the one where the bigger number is negative, you're right. Why do I not need to do the one where the bigger number is negative? It's because b is positive. So when I add these together, the bigger number is going to have to be the positive one. So when I add them, I get a positive b. So if you're thinking I'm doing twice as much work as I need to, you are exactly right. So I could do negative 3 times 6, and I could do 3 times negative 6, but doing 3 times negative 6, I know it's not going to be that because the bigger number has to be the positive one in order for me to get a positive number when I add them. And hey, look, there it is. There's our pair. It's negative 3 and positive 6. So when I put the numbers in, it's minus 3 plus 6, like so. X minus 3, x plus 6. Okay, so let's try this one. This x squared minus x minus 20 always seems to throw people for a loop because after checking for a greatest common factor, there's not one. It's really easy to see that the c is negative 20, but what's the b? It's negative? Remember, there's no number in front of x. It's a 1, so the b is a negative 1. So this is one where we have a product of negative 20 and a sum of negative 1. And of course, we could do our two parentheses that both start with x. All right, so let's do uh, let's do negative 2 and, well, we don't need to do negative 2 and 10, do we? Because since b is a negative, we know the bigger number has to be the negative one. I don't need to do positive 10 and negative 2 because that would give me a positive number when I add them, and I need a negative number when I add them, so I can skip that one. What about 4 and 5? Again, the bigger number needs to have the negative on it. That's negative 20, and negative 5 plus 4, there it is, negative 1. So our numbers are negative 5 and positive 4. Negative 5, positive 4, and there we go. So that's how you factor when c is negative. as you can see, if you're not paying attention, you could end up doing a very long list for your product in some columns. But if you pay a little bit of attention, you can kind of shorten them a little bit because you can tell based on the B whether your bigger or smaller number needs the negative on it. It's really nice whenever your C is a perfect square, like minus 16, minus 25, something like that, because then it doesn't matter which one has the negative on it because they're the same number. So that one also reduces your work quite a bit whenever you're factoring these.